Hi, my name is Dave Kleidermacher, and at Google, I lead the security and privacy engineering teams for Android, Google Play, and Made by Google products, which include Nest and Fitbit devices, apps, and cloud services. This is perhaps the most important talk that I've given in my 30 years in tech. I'm going to describe the 4 most important global challenges in consumer digital safety and the top-level strategy for solving them, all in about 20 minutes. The 4 grand challenges cross all the major dimensions of our digital lives and our digital society. First, we have the services that manage our private content, such as our photos and private social network posts. Then we have the services that provide public content, such as apps, news, and open social networks like Twitter. Then we have the controls to protect access to the data, credentials, and accounts related to the digital services, products, devices that we access, whether they be public or private. And finally, across all these dimensions, we need transparency in the safety and nutritional content in the digital products and services that we use. Okay, so a little bit more detail on the grand challenges. 1, today we entrust a tremendous amount of our personal digital data to cloud application providers. I mentioned photos and private social networks, but also our email, our messages, videos, our entire digital history and behavior. The increasing adoption of the cloud for our digital lives brings privacy and hacking risks. And barring any fundamental change in strategy, we can expect these risks to grow over time. 2, our digital society depends heavily on public content platforms, including apps, audio-visual media, and social network posts where we download, consume, and interact with content. But many of these platforms have gotten so enormous that finding the safest and most nutritious content has become difficult, and criminals and hackers have found their users to be increasingly profitable to abuse and exploit. 3, today when you buy food and medicine, you see an ingredients label and have some assurance that the product has been independently vetted for safety. But in the digital world, we have no clue about the security and privacy ingredients in the products we use. We lack a trusted system for independently vetting those ingredients. This leaves us in a perpetual state of ignorance and fear, and it makes it very, very difficult for us to make safer digital product choices. And 4, the world sadly continues to suffer from inconvenient and weak access controls to our most sensitive online and physical spaces. Okay, so now the 4 grand solutions. The solution to managing massive scale personal data services is private computing. The solution to managing massive scale public content stores and spaces is radical curation. The solution to the need for digital product security and privacy transparency is the certification label. And the solution to weak access control is the next generation digital wallet. And I'm going to review each of these in turn. So let's jump into private computing, and we start with a definition. Private computing is the technology paradigm wherein users retain exclusive access to their private information processed by systems and services. No other entity, the service provider or anyone else, has access to the plain text information. Now, the promise of private computing dawned on me in a big way around 2014. End-to-end encrypted messaging apps were going mainstream, and I started wondering whether we could retrofit the same kind of privacy in other personal information services. I actually toyed with the idea of starting a company to implement this as a layer on top of Facebook. I called it SecureBook. Imagine if all your Facebook posts were encrypted with a key accessible only to you and your Facebook friends. Your personal information would never be accessible to Facebook employees or anyone else other than your friends and family. Now, I don't intend this as a slight to Facebook. This is how social networks were developed. And Facebook has been investing in privacy-preserving technologies throughout its communication suite. But it's a good example to show how the tech world overall needs to do better. Now, like mobile, cloud, and AI first computing, I believe private computing will eventually be viewed as one of the most important technological shifts in technology, and especially in computing. It may seem self-evident why. Obviously, like user expectations for privacy are growing very rapidly. Computing can evolve to deliver helpful and delightful information services without forfeiting the user's exclusive control over their private information. And therefore, computing must evolve. Now, private computing is also going to unlock the true power of ambient computing, which is another really important technological shift. Privacy regulations have created stovepipes and user consent fatigue. In order to collect and share information between compute entities and systems, users are bombarded with consents and privacy policies that they don't have time to read and written in obscure language. This friction ultimately doesn't scale. In a future ambient world, the devices surrounding us are constantly sensing what is happening around us, and it applies intelligent processing to this ambient information to deliver even more helpful experiences. But that sharing can't easily occur across devices and accounts from multiple vendors because the user must understand and consent to that sharing, which may include pushing sensitive data into multiple clouds. In a private computing world, sensor data can be encrypted and shared within a personal secure enclave, residing either within your local devices or in the cloud, where it is securely decrypted and processed ephemerally. Now, while many assume that obscuring the data from service providers with encryption will cause an untenable loss in intelligence, in this case, private computing can actually enable more data to be leveraged to improve our lives without ever asking the user to give up control of that data. We have ourselves an intelligence paradox. And since we can't possibly store all of our personal content on local devices, the what happens on your device stays on your device promise is really a false promise because it simply doesn't scale. Today, we already have the technology to enable privacy-preserving computation that can extend from the edge to the cloud. And finally, it's not enough for Google to solve this for Google's first-party services. We all need to work together as an ecosystem to build and integrate platforms and APIs that will enable any service provider to deliver private computing solutions and to leverage the technology to solve some of the world's most pressing problems that require a more flexible and private information processing architecture. For example, the ability to privately process ambient data will enable aging in place and will enable humans to live longer and better lives. Now, the good news is that we've been quietly building private computing solutions, and it's not just for end-to-end encrypted messages. Android has been doing end-to-end encrypted backups, for example, for years, still the only major mobile operating system to offer that, which may be surprising to some. Now, on the enterprise side, we have cloud confidential computing and end-to-end encrypted documents and workspaces. And there are many, many other examples you see here on the slide. We've also been hard at work developing the core infrastructure components, such as differential privacy and federated learning, to enable private computing across different hardware platforms, again, from edge to cloud. Now let's switch to the problem of safety in public content platforms. Today's massive scale content platforms remind me of massive software applications that used to run on non-memory protected operating systems. Many years ago, I was working with a large network equipment provider who had 3 million lines of spaghetti code running in a single process. The developers suffered from a constant stream of bugs. The complexity was simply unmanageable. They realized they needed to decompose the system and pull out the most critical code into smaller components that would be strongly isolated from the rest and could undergo a deeper automated as well as manual analysis for quality and safety. Of course, that's how we now build safer, higher quality software nowadays. In this example here, you can see how in Android, we not only decompose the system into services, into different components running on top of the Linux kernel, We even pull out supercritical components and run them in separate trusted execution environments, and even in some cases on separate discrete hardware components. If you can limit a critical component to somewhere from a few thousand to up to 50,000, say, lines of code, you can not only run many different analyzers on it, but you can actually afford to manually review every single line of code very carefully for bugs and security problems. And you can even apply formal methods to prove security properties and functional correctness. So now let's take that example. Let's look at the massive scale content platform, such as an app store. Now, the major app stores have millions of apps. While the entire store is reviewed for policy compliance, the size of the store is actually too large to do that in a very deep way, such as by manually reviewing the entire software code base in every app. Apps often include a ton of third-party libraries. Many apps are millions of lines of code, and they can even dynamically change their behavior by downloading content from the web. So you cannot rely only on automated scanners. Detecting whether an app is abusive is an undecidable computing problem. And so we have lots of human security engineers, independent researchers, and pen testers who all join in to help with this. But how long would it take to thoroughly reverse engineer and pen test a million-line application? Now multiply that for the thousands of apps submitted to stores every day. Okay, there's also a ton of tension between curating a nutritious set of apps, which relies on the values and the opinions of App Store editors, with the desire to have an open and unopinionated experience where users get to decide what is nutritious to them. So on this slide, I have a bunch of App Store examples to make the point, but it's obviously not specific to any of the app stores. They all have a similar problem. For example, on this slide, you see a New York Times article noted that found location selling SDKs in both Android and Apple app stores. This tension impacts all massive scale content platforms, and it's not just app stores. YouTube, Facebook, Twitter, TikTok, all of them have a similar challenge. Okay, so now going back to our spaghetti code analogy, we can decompose massive content platforms into highly curated sections. This could be something like the kids section on the Google Play App Store, which we have today. Each app is not only reviewed by Google, but it's also actually manually curated by teachers. This level of curation is feasible for thousands of apps, not for millions of apps. Think about this for Twitter, which today many people feel has grown toxic. The reviewers at Twitter can't possibly read and verify every tweet, and algorithms will never be perfect. But what if Twitter offered micro communities where each tweet can be reviewed, manually reviewed, for nutritious compatibility with that community? Then a user gets to decide if and when they want either the open Twitter megaphone or if they preferred to work within these smaller, highly curated communities. Now, the reason that radical curation works is that it turns out that the vast majority of installs, views, and engagement comes from a very small percentage of the total published content. So content platforms can offer super curated, safe, and nutritious experiences that cover the vast majority of what people are engaging with. And for the rest, again, they are still present, they're available. It's just made super clear to the user when they are venturing into these less curated spaces where your mileage may vary. Essentially, you can have your cake and eat it too. Consumers can have safer, more nutritious, and opinionated spaces while still having the option to participate in more open and unopinionated spaces. One more example, spam. I'm sure this is near and dear to the hearts of many of us, whether it be IM or phone call spam. What if these services offered an option in which messages and calls that come from someone other than a known contact or a highly vetted business entity is automatically pushed into the spam bin? As the user, you can choose whether you want that more curated approach or a more open experience that relies on algorithms or algorithms alone. Moving on now to transparency and the security and privacy ingredients in digital products. Today, the IoT, the Internet of Things, is affecting consumers in profound ways. Not only are we constantly connected, we're putting more and more of our lives in the hands of connected digital technology. Yet today we lack a way to measure the security quality of these products. And so consumers have no idea what they're getting. But we know they're getting a lot of products with dangerously poor security. And just like we have a right to transparency about ingredients in the foods we purchase, we deserve similar transparency in the security and privacy ingredients in the digital products we depend on. IoT security today is like food and drug standards in the 19th century. The lack of standards and labeling led directly to consumer risk and harm. If we can achieve this transparency at scale, it will be the tide that raises all boats because it will enable differentiation that consumers value, and that value will drive demand for healthier alternatives, similar to how we've seen improvements in industries across the range due to the use of standards-based product measurement and ratings. Now, I can tell you from personal experience and some scars that traditional security certification programs used over the past several decades and established mostly by government bodies simply does not scale for the IoT and the pace of change in consumer electronics. But I'm happy to share that over the past few years, Google has worked with about 500 other organizations in building a practical IoT security and privacy certification program that scales across devices, apps, and cloud services and offers multiple levels of assurance, including self-attestation that records a vendor's public commitment to best practices, as well as certification based on independent lab testing. Now, we've done this work within the Internet Secure Things Alliance, working with other companies like Facebook and Amazon and T-Mobile and Comcast and the Zigbee/CSA Alliance and many others. We have many great lessons learned, and we're now helping other certification schemes across the world with the same ideas. With this initiative, it will soon become common to see a live label, such as a QR code within a product's UI or on a product website, that will take users to the certification page that shows the real-time security ingredients and status, because security is not a static idea. It's constantly changing, and we need independent researchers that are constantly pressure testing those security attestations. All of this will enable users to make better decisions about protecting their digital lives. Now, we also apply this concept to the Android device ecosystem. Google certified Android devices already meet baseline security requirements. So we extended the baseline to include additional opportunities for differentiation, including the security quality of the biometric sensor and the lifetime and the frequency of device security updates. So device manufacturers will get higher scores for their ability to offer enhanced security over that baseline. This is a good example of the kind of flexibility we need in assessment programs while still ensuring that the requirements are kept relatively simple and understandable for consumers and developers. We also extended the baseline to cover mobile app security, leveraging guidance from the OWASP Mobile Security Project. Until now, no scalable consumer mobile app security assessment program existed, perhaps surprising to many. Not only are we certifying Google apps and encouraging the certification of other Android apps in the ecosystem, we're also going to be adding transparency around those assessments to our recently announced safety section in apps listed on the Google Play Store, where developers document the personal data their apps collect. Again, this will be the tide that raises all boats, enabling consumers to make better decisions about which apps to install, while giving app developers a way to independently assess their security and privacy practices while differentiating the security quality of their apps. Now, finally, our last grand challenge, bringing convenient and strong access control to our online and physical spaces through next-generation digital wallets. Imagine a world where your digital wallet contains virtual manifestations of any key or credential used to access your online accounts, your car, your home, or to prove your age and other identity attributes to authorities or service providers in the most privacy-sensitive way possible. In businesses with even 100 employees, if you're using passwords to protect remote access, your business is literally guaranteed to be hacked if attackers set their sights on you. At Google, with north of 100,000 employees, unphishable security key access has thoroughly eliminated that threat. And now we've made it so that an Android device offers a digital wallet with a built-in security key, and we've worked with the FIDO Alliance to build standard protocols and APIs for developers to incorporate what's really a miracle of unphishable authentication to any service. Yet sadly, most of us are still forced to use single-factor passwords on many of our online accounts. We're working to improve our APIs and to make unphishable auth even easier to integrate by developers, and to ensure all users' FIDO passkeys are at the ready within the digital wallet. Making our personal data much more private, making public content platforms much more nutritious and safe, while still offering open and unopinionated content choices. Building the security and privacy ingredients labels into the Internet of Things. And turning our personal mobile devices into super convenient, unphishable authenticators and digital wallets. These are the 4 biggest opportunities in digital safety of our generation. To realize their huge potential, we need to work together. We need to drive new strategies, not within walled gardens, but rather within open standards, partnerships, and thriving ecosystems. I covered a lot of ground in a short period of time. I hope you're intrigued, and I welcome your feedback and engagement. Thank you.